Yes, now we want to get to know a formula that looks very complicated at first glance, but upon a second look, we have probably already applied it intuitively. We will see this in the example that we will calculate. I also think that the formula can be explained intuitively quite well. Exactly, we have the following situation. So we have our set omega, and we have a so-called partition of omega. This means we have divided the set omega into different subsets that are mutually exclusive, e to n. And I would like to go through that with you in detail, step by step, using an example. Imagine omega. You are a car dealer, and omega is the set of all cars. Then, a partition might potentially be that they divide the set of cars into brands, for example, or categories. Imagine this. You have all your cars, and you categorize all these cars into different brands, VW, Audi, and so on. Then these events are mutually exclusive because one cannot be two brands. And now imagine that we want to calculate the probability of an event called red car. Then there is the following. Imagine this is your omega, which is now represented schematically. This is our omega 2001, and this here is the set of red cars. So this is our A. And now imagine we can further divide this omega into the different brands. This looks like, let's say, there are 3 brands. Then it looks like this. And what we can do now is we can take a look at this. So this is brand 1, SOS, EOS. Yes, brand 1, brand 2, brand 3. And what we can do now is, if we want to calculate P of A, then we can look at P under the condition M, P with M, or the intersection of M and PM. And in the end, we just need to form the sum. I will write the sentence now. I have drawn the sentence here. And then we can take a look at how this relates to our example. So we have our partition and an event, for example, a red car. Now let's take a look at this part here. So in the end, for our example, if we want to calculate P of A, it is simply the sum of P of a intersecting M plus P of a intersecting M plus P of a intersecting M. Why? Well, a cut M, and a cut M are mutually exclusive. Why? Because a car that is a red VW cannot simultaneously be a red BMW. And then we know that we have seen this in the actions of probability when we have mutually exclusive events, and we want to find the probability of the union. Then we can simply form the sum. And what we can do now is, well, we have clarified the first part of the task. So we have now clarified this term here. Oops. And now we can also make use of the multiplication rule. 2001. And the multiplication rule states that the multiplication rule Exactly, so we have this now, and now we can also refer to the multiplication theorem, which illustrates a relationship between this thing here and this thing here. And so thus we obtain the formula for the so-called total probability. So we need to know what the probabilities are for the individual brands, let's say. What is the share of M, M, and M? And then we need to know what the probability of red is under the condition of brand 1, under the condition of brand 2, and so on. Yes, using the axioms once and then using the multiplication theorem for the second time. And now we will provide an example that goes in a very similar direction. We have a computer manufacturer that sources hard drives from 3 different suppliers in varying proportions and of different quality. And this table describes what we have here now. And now we can already see that E is the first supplier, and E is then the second supplier, and E is the event, supplier 3. And we see that these events have probabilities of 40%, 25%, 5%, and 30%. So, we are interested in things. A means defect, so how much is broken? And we only know, what do we know here now? So we know what is stated in the table. And so they know tables. And now perhaps you still wonder, what do these tables mean? Well, that means that the probability of defects under the condition of supplier 1 is 0.02, P is 0.01, and P is therefore 0.03. So, if we want to determine the probability of A now, according to the formula we just learned, and you will also see that this would probably have been intuitive, we need to multiply the probability of A given E, which is 0.4, times 0.02, meaning you weight the 2% with the 40%. They are doing the same thing here, with the 1%, and then doing the same here, with the 3%, and then they calculate everything. And that is the result for the probability that there is a defect. And as I said, I think they have most likely done that before. Now we have a formula for it that provides a good justification for why this is correct. And we will need that again in the next formula, in the next video. The formula from Weiss, which is probably the most complicated formula for this week. But then we have made it, and then we can also calculate our corona example. Until then, take care.